Hi guys, my name is Joost. I'm here with Thijs, and we're here to speak a little bit about feature stores and the work we did for that at Adyen. As you can see from the slide, I'm no longer part of Adyen, but I guess we left on such good terms that they still agreed to let me do this talk. I'm doing this talk with Thijs. It will consist of two parts. So in the first bit, I'm basically going to give a whole bunch of context. I found this quite useful from previous iterations of the Apply conference that we watched while doing the work. So we're returning the favor here. Thijs will do the second part, in which we will discuss the plugin that we developed in order to make sure that we can run Feast on our infrastructure at Adyen. Yeah, so in the next slide, there's a bit of introduction about Adyen. We are a payment company. Basically, if you're a business and you want to accept money from shoppers, Adyen can help you do that. You can see a bunch of colorful logos of companies that already trust us. And as you can see from the numbers, it's quite a big company. So we process big amounts of money. So yeah, in the next slide, we listed a few of the use cases that Adyen uses machine learning for. I think many people can predict that credit card fraud is something that we want to prevent, and we use definitely we use ML for that. Another use case that is a bit maybe more new is like the fact that payments fail. Of course, it's not new, but payments do fail, and a common case for payments failing is that people don't have money in their account. Later in the month, they might have their salary, so you can use ML to predict when is a good time to retry the payments. And like that, there are many use cases. So in order to support all these use cases, at Adyen, we built an in-house machine learning platform. So in the next slide. Important to know about this platform that everything is hosted on premise. So early on in the history of the company, Adyen made the decision to not use public cloud. So we have to host everything ourselves. Some other facts and figures of our ML platform. We release a couple model versions every week, process quite a large volume, and many of these machine learning models are also part of the real-time payment flow, right? So we have some low latency and reliability constraints to that. And as you can see, over the last years, the ML team has grown quite a bit to a sizable organization. So it was very fun to be able to work on all this. On the next slide, we're getting near to feature stores. So this is a basic timeline of the last year and the major milestones we had in implementing a feature store based on Feast. So a bit more than a year and a half ago, there was no general purpose feature store at Adyen, which was a very sad time. It's very difficult for data scientists to reuse the feature engineering efforts they did. And that's why we decided to implement one actually based on Feast. 0.8 was the first version we used, so a long time ago. We saw quite some adoption. People liked it, and that's why we kept developing. And then at the end of last year, we were able to upgrade to a recent version of Feast, 0.14, and at the same time develop a plugin to make sure that we can run Feast on Spark, which is the main data processing tool that we use. And then quite a few months ago, this plugin was moved into the main Feast project, which is also a main reason we're here today. And then the next slide is sort of a mandatory feature store diagram slide. I always appreciated this a lot. This gave us a lot of confirmation that we were building something sensible. Basically on the right side, you see the part where Feast is really living at the end in our big data / machine learning platform. It's an Hadoop platform. I'm not an infrastructure engineer, so I'm probably forgetting a bunch of important technologies. We use HVS for storage and Python and Spark for processing. And we use Feast basically only here. So on the left side, you see the real-time payment processing platform with the online feature store. You can see there everything is based on Java and Postgres, and we built a very custom solution. So this is definitely a part where we see some future improvements, and also something that Adyen is still working on. I think that the rest of the presentation will focus mainly on the right side and the component called the Spark offline store. So Thijs?
Thanks, Joost. So yeah, the Feast Spark offline store, in-house built package, because I'll explain a bit why we really needed to build this. But of course, it's for Feast, the open source feature store. In earlier versions, Spark was supported in Feast, but later they decided to move it out of the main repo. And then other repos became incompatible that were focusing on Spark and Feast combination. So we really needed something to interface with it. And the reason for it was that at Adyen we have there was the most wanted offline features were like aggregations over day ranges, larger calculations that like every feature store has facilitates. And a lot of our internal ETL pipelines were of course calculating these features using PySpark. And of course, Feast interfaces nicely with Python, and we were using Spark internally as well. So we needed some consistency, and we wanted to promote feature reuse within the company. So we wanted a familiar looking interface to, instead of having like adapters that we built customly. So we wanted to have consistency with the actual Feast repo and set up a custom plugin. So we decided to build this first in-house and then see if it got adopted, and then maybe later open source it. So then we started building the Spark offline store, basically followed the templates, and we followed the templates of BigQuery and Redshift. We could really see these nice examples and focus on the consistency between these, and it was really easy to develop this way. So here's an example of what it looks like. Basically, you can use Spark to read your different, your files or tables that you have in maybe your Hive meta store, or put an SQL query directly in it, the usual way. But it uses the data source objects that Feast uses to interface with. You can also configure your Spark session, your Spark configuration. You can add it to your feature store YAML. It's not necessary though. You can also just, if you have already a Spark session running, that's also fine. So we got some buy-ins on adoption within the company. Then we were like, okay, we need to open source this. We need to give back to the community because we're using Feast a lot. And that was great. We got like some comments, some pull requests from other people. And then at a certain point, we got a contact by the main contributors of Feast if we wanted to add this to the main repo, which was recently done. So big thanks to Kevin and Danny, who are, I think, also giving a talk at this conference. It's currently in the alpha status, so beware still a little bit, but it will continue to be worked on. And so the conclusion for us is like we've seen, the feature store is a valuable part of an ML platform. We've seen a lot of buy-in within Adyen. We built a lot of custom logic, but Feast is valuable to provide good abstractions and guide the engineering thinking. And over time, the custom logic became less and less needed with new Feast upgrades. Feast is extensible to fit diverse tech and infra constraints. So we like the new direction. And to conclude that our experience in creating a custom plugin was very smooth. That's it. Thanks.